Hello everyone, welcome back. I am Fizam Muskan from Sri Venkateshwara College of Engineering, Bengaluru. Today I'll be discussing about four-stroke petrol engine, which comes under the subject Introduction to Mechanical Engineering. Before learning about four-stroke petrol engine, let us know what are IC engines. Here is some brief introduction to IC engines. An internal combustion engine, also known as ICE or IC engine, is a heat engine in which the combustion of a fuel occurs with an oxidizer, which is usually air. In a combustion chamber, that is an integral part of the working fluid flow circuit. And this is how an IC engine looks like. At the TDC is the rocker arm, which is connected to the push rod and camshaft. And at the TDC, there is a valve, which are of two types. One is intake valve and the second is exhaust valve. The blue region below the valve is known as combustion space, where the air-fuel mixture will be present. Below that is the piston, which is connected to the connecting rod, then crankshaft and crankwheel. We will discuss about the parts of IC engine briefly in the next slide. So coming on to the parts of four-stroke engine. The first part is the piston. In an engine, a piston transfers the expanding forces of gas to the mechanical rotation of the crankshaft through a connecting rod. And there is the crankshaft, which is a part that converts the reciprocating motion to rotational motion. And there is connecting rod. It transfers motion from a piston to crankshaft, acting as lever arm. Then comes the flywheel, which is a rotating mechanical device that is used to store energy. And comes the inlet and outlet valves, also called as inlet and exhaust valve, which allows to enter fresh air with fuel and to exit the spent air-fuel mixture from the cylinder. It is a device that delivers electric current to the combustion chamber, which ignites the air-fuel mixture, leading to the abrupt gas expansion. Classification of IC engines. IC engines are basically classified into many types. Here, we'll be discussing about one type, which is according to the number of strokes per cycle. There are usually two types based on number of strokes per cycle. They are four-stroke engine and two-stroke engine. Four-stroke engine. In this type of engines, the working cycle is completed in four different strokes, which we will be discussing today. Then comes the two-stroke engine, in which the working cycle is completed in only two different strokes. So coming on to four-stroke petrol engine. The working principle of a four-stroke petrol engine is based on theoretical Otto cycle. The four strokes of the engine go by the following names. The first is suction or intake stroke, compression stroke, power or combustion stroke, and the last is the exhaust stroke. Here is the diagram of all the different strokes present in the four-stroke petrol engine. The PV diagram for four-stroke petrol engine is as follows. From A to B, the suction of air and petrol takes place. Then the compression of mixture takes place, where the pressure increases. And from C to D, constant volume combustion takes place. And expansion stroke takes place, during which the pressure decreases. Then the exhaust valve opens, which is marked from E to B, and the exhaust of combustion product. And hence, it is known as reversible adiabatic process. Suction or intake stroke, which is the first stroke of four-stroke petrol engine. Intake stroke occurs when the air-fuel mixture is introduced to the combustion chamber. In this stroke, the piston moves from TDC, top dead center, the farthest position of the piston to the crankshaft, to BDC, bottom dead center, the nearest position of the piston to the crankshaft. The movement of the piston towards the BDC creates a low pressure area in the cylinder, as we have seen in the PV diagram of the four-stroke engine. The inlet valve remains to open a few degrees of crankshaft rotation after BDC. The intake valve then closes and the fuel air mixture is sealed in the cylinder. Key points to remember are: inlet valve is open during the suction stroke, outlet valve is closed, and the crankshaft rotation is around 180 degrees. Compression stroke. In compression stroke, the trapped air fuel mixture is compressed inside the cylinder. During this stroke, the piston moves from BDC to TDC, compressing the air fuel mixture. The momentum of the flywheel helps the piston move forward. Compressing the air fuel mixture allows more energy to be released when the charge is ignited. The charge is the volume of the compressed air fuel mixture trapped inside the combustion chamber, ready for ignition. The inlet and outlet valves must be closed to ensure that the cylinder is sealed, resulting in compression. Key points to remember in compression stroke are: the inlet valve and the outlet valve both should be closed, and the crankshaft rotation is 180 degree and the total is 360 degree. Power or combustion stroke. The second rotation of the crankshaft begins when it completes the rotation during the compression stroke. The power stroke occurs when the compressed air fuel mixture is ignited with the help of a spark plug. Ignition or combustion is a rapid oxidizing chemical reaction in which a fuel chemically combines with oxygen in the atmosphere and releases energy in the form of heat. The hot expanding gases force the piston head away from the cylinder head. Key points to remember in power combustion stroke is: both the inlet valve and the outlet valve is closed, and the crankshaft rotation is 180 degree. The last and final stroke, which is exhaust stroke. As the piston reaches BDC during the power stroke, combustion completes and the cylinder is filled with exhaust gases. Exhaust valve open during this stroke and the inertia of the flywheel and other moving parts push the piston back to TDC, forcing the exhaust gases through the open exhaust valve. At the end of the exhaust stroke, the piston is at the TDC and one operating cycle has been completed. This process repeats. Key points to remember are: inlet valve is closed and the outlet valve should be open in the exhaust stroke, and the crankshaft rotation total is 720 degrees. Here is a 3D animated video of how a four-stroke petrol engine works. We can see all the parts over here. Over here is the piston. This is the crankshaft. This is the connecting rod between which is connected. This is the connecting rod which is connected to the piston and the crankshaft. Let us see how this works. Now the piston was at TDC, which is coming down at the BDC. This is the combustion area where the fuel mixture is present. The crankshaft has started rotating. This process repeats. The fuel mixture present in the combustion area is now getting compressed. This is how a four-stroke petrol engine works. Coming on to the result and conclusion. This four-stroke IC engine will complete its all four-stroke cycle in one revolution, due to which it will increase the efficiency and torque of the engine. This IC engine with double cylinder and double piston give proper and appropriate combustion timing and produce high energy.